in behavior of polynomial functions. In behavior of polynomials. Now you can determine the end behavior of a polynomial by simply determining or looking at the leading coefficient and the degree of the polynomial. So in other words, whether it's odd or even. So for example, even degree polynomials will be those polynomials that will either rise up, both ends will rise up, or both ends will fall. Now the little dash that you see in between, that just simply indicates that you can have several turning points within that polynomial. And again, remember that's based on the degree of a polynomial n minus 1. But regardless, for even degree polynomials, they will either rise up or they will fall. And what determines that? Well, it's the leading coefficient. So if the leading coefficient is a positive number, then your polynomial is going to rise up. And if that leading coefficient is a negative number, then your even degree polynomial is going to fall down. So again, if the leading coefficient is greater than 0, meaning a positive number, it's going to rise up both ends. If the leading coefficient is a negative number, such as in this case, the leading coefficient is -1, so that is why this even degree polynomial in the second example would be one that would be both ends would face downward or fall. Now with odd degree polynomials, its behavior of the graph or its shape is also going to depend on those two things, the leading coefficient and the degree. So as far as the degree, we know that if the degree is an odd degree, that is going to fall on one end and rise on the other end. So depending on how it does that, and again, that's a from left to right motion, it's the leading coefficient that's going to determine that. So if the leading coefficient is a positive number, a number greater than 0, from left to right, it is going to rise up. So you'll notice that on one end, the arrow is going to be facing downward like a fall, but on the other end, it's going to rise up. So from left to right, it's going to rise. And then if the leading coefficient is a negative, such as in this case, the leading coefficient is -1, it's going to fall from left to right. So it starts out with a rise and it falls down. So from left to right, it falls if the leading coefficient is a negative number. But yes, you can tell a lot about the shape of a polynomial function by those two things, the leading coefficient and the degree of the polynomial, because if it's an even degree, both ends is going to face up or down, and it's the coefficient that determines whether it faces up or down. If the leading coefficient is positive, it faces up. If the leading coefficient is negative, it faces down. And then if you have an odd degree polynomial, it's going to be those that have that sort of S-type shape where one end is going to rise and one end is going to fall. Now, depending on how that happens, it's the leading coefficient that determines that. So if the leading coefficient is a positive number, such as in the first example, from left to right is going to rise up. And then if the leading coefficient is negative, such as in this case, it's a -1, from left to right is going to fall. And that is the end behavior of polynomials. Okay, so I've explained odd and even degree polynomials in the previous slide. So if you haven't seen that, please rewind the video so that you can get an idea of the difference between an odd and an even degree polynomial. This is simply a practice to see how much you remember. So number one, would you say that is an odd or an even degree polynomial? Well, if you said odd, that is correct, because recall odd polynomials, their end behavior are opposites. In other words, one end is going to fall while another end rises, or vice versa. But the bottom line is you're going to have a rise and fall, or fall and rise. So yes, number 1 is an odd degree. How about number 2? Yes, that's correct. Another odd degree polynomial. Number 3. Number 3, if you said even, you're correct, because remember, for even degree polynomials, both ends will either face down or up. And as far as them facing down or up, remember what determines that would be the leading coefficient there. But in this case, we're just simply want to determine whether these are odd or even. We don't really care at this point whether they're facing up, down, rise, or fall. Just looking at it, I want to know if you're able to determine whether they're even or odd degree. So moving on, number 4, what would you say that is? If you said even, that is correct, both ends facing up. Number 5, yes, number 5 is an odd degree, because notice the end behavior there, they're facing in opposite directions. And number 6, if you said even, you're correct. Good job. So if you had trouble with any of that, just please rewind the video so that you can get a better understanding or clarification of the difference between an odd degree or an even degree polynomial. Next, we want to identify the graph of polynomial functions by using the end behavior. So we want to know which of these graphs, A, B, C, or D, is the graph of the polynomial function f of x equals x to the 4th power minus x squared plus 5x minus 4. Well, first of all, we want to look at what is the leading term. So the leading term, remember, is, if you look at all the terms, is the term that has the highest degree. So in this polynomial, the leading term is x to the 4th power. Well, what is the sign of the leading coefficient? We recall that when we don't see anything in front in terms of a numerical value, we understand there to be a 1 there. So the leading coefficient, the sign of it, of that 1, is positive. So that's a positive. As far as the degree of the polynomial, out of all the degrees, the highest degree is 4. That is a 4th degree polynomial. 4 is an even number. And what do we know about even polynomials? Well, yes, what we know is that with the end behavior, they're going to be either both ends facing upward or both ends facing downward, which means there's no way possible it could be choice B or D, because choice B and D represent an odd polynomial. So B and D are out. It's either going to be A or C. Now, as far as which one it is, well, let's take a look at that leading coefficient. Since the leading coefficient is positive, that means that it is going to be facing upward, which means it is choice C. Based on the end behavior, it would be a graph where both ends would be facing upward, because the leading coefficient is a positive number. And there you have it. Let's take a look at another graph. Which graph matches the function f of x equals negative x to the 7th plus x minus 4? So we want to look at the leading term out of all the terms. The term that has the highest degree is, in this case, the first term. That is a term that have a 7 degrees, so this is a 7 degree polynomial, which means that 7 is an odd number, so it's an odd degree polynomial, which means one end is going to be facing up, one end down. Well, what determines those ends would be the sign of the leading coefficient, and the coefficient of the leading term is -1. So that's a negative number, which means that from left to right it's going to fall. So in other words, it's going to start out with a rise and then fall. We can already cancel out choice A and C. There's no way possible it could be A or C because A and C are even degree polynomials. So we are looking at it to be either B or D. And based on the sign of the leading coefficient, it is going to be a graph that starts out with a rise and then it falls, it ends up falling because of the sign of the leading coefficient, and so that matches graph D. Let's see if you can do this one on your own. Which graph matches the function g of x equals -x⁶ plus x squared minus 3x minus 4? Well, let's take a look at the leading term out of all the terms. The one with the highest degree is that first term. That's a degree of 6. 6 is an even number, so this is an even degree polynomial. We know that the behavior of even degree polynomials will either face up or down both ends, so that means it cannot be B or D. It has to be A or C. Well, let's take a look at the leading coefficient. Since the leading term, the coefficient there is -1, that's a negative number because it's negative. Both ends then is going to face downward. And yes, that is graph A. So was that the graph you already suspected to be? If so, you're doing a great job. And if not, no worries. Just go back and rewind the video to review. Which graph matches the function h of x equals 3x cubed minus x squared plus 2x minus 4? Well, let's take a look at the leading term out of all the terms. The term that has the highest degree is again the one here out front. So if they are not in order as they should be, all in order from greatest degree to the lowest, but if it's not in order, for example, if you're doing your homework on my math lab and you notice that it's not in order, remember the leading coefficient is always going to be the term that has the highest degree. The leading term there would be 3x cubed. The degree of that is a degree of 3. 3 is an odd number, so this is an odd degree polynomial, which means one end is going to rise, one end is going to fall. So we know it's going to be choice B or D. In terms of which one it is, let's take a look at the sign of that leading coefficient, and the coefficient there is a positive number, +3. And since it's positive, that means this is going to be a graph that from left to right that is going to wind up rising. So it starts out with a fall and then it's going to end up rising, and so that is going to be in line with graph B. Last practice problem. Describe the end behavior of the graph of the polynomial function f of x equals 9x6 minus 3x to the 4th power plus x squared minus 2. So the leading term is 9x to the 6th power. That is an even or odd degree. If you said even degree, that is correct, which means what? Yes, it means that the end behavior, that both ends is going to either face upward or downward, so there's no way possible A or B could be it because A and B are odd degree polynomials. So let's determine whether it's C or D. What determines whether they face up or down? Well, recall, it's going to be the coefficient. And since the coefficient here is a positive number, it means it is going to be a graph where both ends are going to face upward, which is choice D. And there you have it, using the leading term, its degree, and the coefficient of that leading term, using that to determine the graph of a polynomial function based on the end behavior. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.